If you want to make money in the tech industry, the accepted plan is pretty simple. Find the smartest product and ride it to the top. Apple built the iPhone, and it crushed the competition. Google built the best search engine, and it turned into one of the most profitable machines in history. The assumption is that artificial intelligence should work the exact same way, but the actual numbers tell a completely different story. In 2025, the company that put ChatGPT into practically every language on Earth booked $13 billion in revenue. That same year, it lost roughly $38 billion running its business. By its own internal projections, it is on pace to burn tens of billions more every year for the rest of this decade, before it expects to see a single dollar of real profit. Compare that to a hardware company that, a decade ago, most people outside of finance had never even heard of. In its last fiscal year, it posted nearly $216 billion in revenue. And it did that with a gross margin of 75%, selling physical silicon, wire, and heat. The entire sector operates as a heavy capital expenditure industry that happens to produce intelligence as a byproduct. To make money here, you do not need to build the smartest chatbot. You need to own a piece of the toll road that every single AI lab is required to drive down. To see how that money actually moves, we have to start at the absolute bottom of the supply chain. Every AI chip, before it can process a single line of code, begins as a design that has to be printed onto silicon using extreme ultraviolet light. ASML manufactures the machines printing advanced AI chips. Costing $400 million each, they hold the extreme ultraviolet lithography market with no competitor. Move one layer up. Once etched, chips must be assembled. A single Taiwanese company does the overwhelming majority of this precise work globally. Right now, that capacity is sold out into 2027. When your product physically cannot ship fast enough to meet demand, you don't have to compete on price. You get to set it. These foundational companies don't care if a chatbot is smart. They just need the industry above them to keep needing more chips. That absolute pricing power is what allows the companies designing the chips to command 75% gross margins on manufactured hardware, a markup most software companies would envy. And the massive cloud providers, the hyperscalers like Google and Meta, are desperately trying to escape it. They are now spending billions to design their own custom silicon from scratch, solely to cut out that 75% toll. But even if they succeed, they run headfirst into a constraint that no amount of venture capital can bypass: electricity. You can build a new data center in a year or two. You cannot build a new power plant, secure the permits, and run the transmission lines anywhere near that fast. In a single year, the power demand specifically from AI-optimized servers is projected to spike 84%. Analysts are already tracking structural power shortfalls across the U.S. grid. Entire multi-billion-dollar infrastructure projects risk stalling out simply because there isn't enough juice on the wire. The local utility companies, who happen to own those power lines, are quietly fielding requests from tech giants who have nowhere else to go. At every physical constraint, whoever controls the scarce resource gets paid. Which brings us back to the famous AI labs at the top of the stack. Remember that $38 billion net loss? Total operating costs for the company behind ChatGPT ran around $34 billion for the year, and $17.2 billion of that, an amount larger than the company's entire annual revenue, went to a single vendor. It was a payment to Microsoft, largely to rent the Azure cloud computing capacity required to train and run their models. Just answering user questions, the daily inference cost, dragged the company's gross margin down to 33%. That is the margin of a struggling brick-and-mortar retailer, before even paying for marketing or human engineers. These labs function as enormously well-funded pass-through mechanisms, funneling investor capital straight down the toll road to the hardware and cloud providers. The business model works exactly as designed. The labs capture the headlines, while the infrastructure layer captures the cash. To keep market share growing while the underlying compute costs so much, the labs are subsidizing the price of admission. When you pay a monthly subscription for a chatbot, you are paying less than the true cost to run it. Venture capital covers the difference. Meanwhile, the hyperscalers are using a quiet accounting choice to make their own profitability look better. They have extended the estimated useful life of their servers from 3 or 4 years up to 5 or 6. This change spreads out the multi-billion-dollar cost of the hardware, instantly creating billions in reported earnings on paper, a practice that high-profile investors like Michael Burry have publicly challenged. And those numbers get even stranger when you look at how the deals are structured. A chipmaker invests billions into an AI lab, which uses that cash to rent cloud capacity. The cloud provider then uses that revenue to buy chips from the original investor. In 2025, one company disclosed $540 billion in circular agreements. The money moves in a loop. A meaningful portion of what gets reported as the AI industry's massive financial growth is the exact same pool of capital. It's just being counted as revenue or investment multiple times by an interconnected circle of companies. That financial loop is currently chasing enterprise revenue that largely doesn't exist yet. Despite billions spent on corporate software rollouts, studies show roughly 95% of enterprise AI pilot projects fail to produce any measurable financial return on a balance sheet. The value being created is mostly invisible. An estimated 90% of employees report using their own personal AI accounts to get their work done, entirely bypassing the approved corporate IT systems in a massive shadow AI economy. But the macroeconomic consequences are highly visible. AI automation is tied to an estimated net loss of 16,000 U.S. jobs a month, heavily concentrated in high substitution roles like data entry, claims processing, and customer service. Major U.S. banks are running technology budgets near $20 billion, explicitly aimed at reducing the labor content of compliance and back-office work. They are hiring thousands of AI specialists, while simultaneously projecting hundreds of thousands of job cuts for traditional roles over the next few years. The systematic focus on automating back-office roles is dismantling the traditional first rung of the career ladder. For workers between the ages of 22 and 30, the path into these industries is narrowing 3 times faster than for their more experienced colleagues. All of this builds to a very specific trillion-dollar math problem. In a single year, 4 hyperscalers guided towards $725 billion in infrastructure spending. Meanwhile, the combined revenue of the most prominent AI labs sitting on top of that infrastructure is sitting somewhere around $80 billion. That massive gap has to close. And because a tiny handful of tech stocks tied to this build-out now make up 35% of the entire S&P 500, the stakes go far beyond Silicon Valley. The retirement savings of anyone holding a standard index fund now depend entirely on whether this capital spending eventually pays for itself. Every gold rush operates the exact same way. The prospectors spend fortunes racing to strike it rich, while the people who own the tools and the land quietly stack cash. If you want to know who is really building a durable fortune from artificial intelligence, don't look for the company building the smartest system. Look for the companies who get paid whether that system wins or not.